Next up, routing. So now this packet travels through the internet. It needs to get from one subnet somewhere, or from an IP address in a subnet, to another IP address in another subnet. And this can technically be anywhere in the world. So now it needs to find a way to get there. And that's where routing comes in. It's almost like the post office, where or a courier company, where you physically send a package to some country or some person in a remote country. You write an address on there. As it goes through to your local depot, to the national depot, to the airport, to the other airport, to their national depot, to their local depot, and to their post office and to their street address. In a very similar way, data that travels through the internet, these packets, are routed. Okay. If for instance you want to send a package to an address in the UK, the local post office, they don't need to know the exact address. They just need to know that this package needs to go to the UK. That's all they need to know. They don't really need to know the finer details. And that's the previous thing I referred to with these bigger subnets. So there'll be a bigger, they'll just look at the biggest subnet, and then they'll know where to send it. Because this company that sends the package will just take this package and send it to the UK. They don't even look at anything else. They just look at the country. The country says UK, they send it to the UK. As soon as it gets to the UK, then they'll look at the second line. What province? And then they'll send it to that province. As soon as it gets, obviously don't look at anything else. They just look at the province. As soon as it gets to the province, then they might look at the city or the suburb. And they'll dispatch it to that post office. Or postal code. That's actually where postal codes come in. So they'll dispatch it to that postal code. As soon as it gets to that postal code, the post office will look at the very last line, which is either a post box or a street address, and then they'll take it further. So in that way, not everybody in the whole system needs to know all the knowledge. You just need to have an idea of where to send this packet. So it's a similar way with routing. With routing, we need to first of all tell all the devices in the network where to send the packet. If it's not in the same subnet, where to send it. If it is in the same subnet, it's usually referred to as on link. Either on link or 0.0.0.0, that would be your gateway. So if you want to see these configurations in your PC, if you're running Linux, in your command line, you can just say root space -r. Then it will just, it might be -n. Yeah, so it's -n actually. -n. Then it will print out all your routes configured on your PC. You'll see there's usually actually quite a list. There's for localhost, for outbound internet, for the local connections, for everything. And the local subnet will usually say the gateway is on link. So it means it's on the same subnet. Or if you want to think about it in, let's say, an addressing system like this, it's almost like it's on the same street. If I tell you to go to an address in the same street, I'm not going to send you directions. I'm just going to tell you go there, and you just go there. You don't need to have directions. You just drive up and down the street until you find the number. So it's a similar thing. If you send a packet to the same subnet, it just sends it. It will get to the same subnet. There's no routing. Okay, and that is referred to as on link. If it needs to go out of the subnet, then routing is required, and that's where a gateway comes in. Now, a gateway typically sits between two subnets, or a minimum of two subnets. It might sit in 3 or 4 or 5 subnets, which actually means that this gateway, it could be a server, it could be a router, actually has 2 or more IP addresses, because it actually needs to have an IP address inside each subnet. So like we have here, we actually also, our server here has 3 IP addresses. It's got a VPN IP, it's got an IP in the 10 range, as well as an IP in that range. And it is our gateway server. So as soon as you want to send a packet somewhere, all our PCs in the network is configured to use our server as the gateway. So as soon as your computer sees that this packet, the IP address of this packet, needs to go outside the subnet, it will automatically send it to our server. And that server's IP is the gateway. And that IP you configure on your PC to say this is the gateway. So it will send it to that IP and say, here's a packet, deliver it for me. Once it gets to the server then also, if you use this command on the server, you'll see that there's routes configured. Then the server will look at its routing table and it will see, where must this packet go now? Then it will send it via one of the 3 IP addresses, depending on the IP range or the subnet of this packet. Okay. Let me just see if I've covered everything. Okay, yeah, like I said, the device must know the gateway's IP. So every device on the subnet or on the network must know the gateway in order to send the packet to another gateway. The gateway typically has more than 2 IP addresses and it sits in 2 IP subnets. And it basically, a gateway also connects 2 subnets together. It sits in the middle. The typical way to draw it is like 2 circles. One's the one subnet, one's another subnet, and the gateway sits in the middle. It's part of both subnets. So if someone on this subnet wants to send a packet to someone on another subnet, he obviously specifies the address and he sends it to the gateway. The gateway will forward that packet in there. And that is called routing, gatewaying, and forwarding. Okay. So you can actually refer to it in 3 ways. It's gatewaying, routing, or forwarding. If you specify routes, the mask, a better way to understand the network mask is a wildcard. It's similar to these here. When you actually want to route a specific IP, that typically becomes like an asterisk. You know, in command line, you can actually use an asterisk to specify a wildcard, which doesn't mean anything. So you can like search for a name, asterisk.jpg, which means it will actually find files in your PCs, which is anything .jpg. So this is a very similar way, where the mask tells you almost where to put asterisks. So in these IPs, that's technically an asterisk and asterisk. That's what your network mask means. If a mask is this, the zeros are typically asterisks, which means it's anything. Oh yeah, just keep note that these aren't the only masks available. These are just the most popular masks, 24, 16, and 8. Those are the popular masks. You can actually have different size masks, like this one, which is 12. But they're not popular, they're not used often. If you run your own ISP, you're probably going to use the other IPs. But if you're just configuring normal networks like we do, you use the standard 8, 16, and 24 masks. Okay. Yeah. Another way to, if it's routing, gatewaying, and forwarding, the whole path from there to there is a single connection. It's seen as one socket, one connection. We'll still get to that when we get there. It is one connection, one communication, one route. Okay. Obviously, as I just previously mentioned, the gateway as well as each device on the network has routing tables that it basically uses lookup tables to know where to forward these packets to. You can also use these route commands to manipulate these tables, to add new routes and to subtract routes. And that's just also going back to this one here, where your routing tables usually doesn't include all the small subnets. It just uses big subnets. For instance, if your gateway on your PC, you can't just specify gateway. You have to specify a subnet, a mask, and a gateway, always. So it's like a route to a specific subnet with a mask, and then use this gateway. But usually what we do then is your default gateway, actually what it does, it adds a route to your PC, which the subnet is 0.0.0.0. The mask is 0.0.0, which basically means you have a subnet which is everything. And the destination is everything. Then you use the gateway. So that means if it's not in the subnet, send it to that gateway. That's basically what it means. Okay. So that's the whole technique. What you're doing is you're configuring a major subnet, which is the rest of the world. And that actually, instead of specifying each of the subnets in the world, you just specify a major one, you say that's the mask, just send it there. when it gets there, it will be routed to wherever. Okay. Yeah, this obviously helps servers on the internet to not contain as many rules. You only need to know what's around you. You don't need to know what's behind that. Yeah, another way to think of a gateway is like a main road that usually connects suburbs. So a subnet can be seen as a suburb, where inside you have lots of houses, which is your IP addresses. And when you want to move from one suburb to another suburb, there's usually a main road that connects the two. You have to get onto that road to get to the next suburb. And that's almost how a gateway works. So you have to go through the gateway. Okay, so an easier way of understanding it. Cool. Does anybody have any questions on this? Oh wait, before we carry on, I just also wrote some subnets down here. So all the PCs on this network or devices is in the 192.168.0.0 range, or subnet. The mask is 24, so if you look at 24, that's our subnet. We've got 253 IP addresses we can add here. This one's 192.168.10.0, also 24, but obviously because it's 24, only the last digit will determine the specific IP. So this one will always, all these addresses will start with 192.168.0 dot something. All these addresses will start with 192.168.10 dot something. Okay. And the gateway, it's got two IP addresses. One is on this network, another one is on that network. Usually, if you have one of these ranges, your gateway is either 0.1 or 0.253 or 0.254. This is your last one, your second last one. That's usually your gateway. Most of the time, the very last digit, you can't use 0, you also can't use 255. Just remember that. So when you specify an address, when you assign an address to your computer, you can't actually use 0 and 255 in the last location. Anything between that, but not 0 and not 255. I think 255 and 0 is sometimes used for broadcasting, but I'm not sure about that. You're going to have to. That's when you want to send a packet to every piece in the network, in the subnet. You just broadcast it, then it will automatically go to all pieces. So you can actually set that up. Okay, now you have. Oh yeah, wait. Sorry, another thing. Here's a typical example of the internet. If a packet needs to go, these circles are all different subnets. But our source is here, so we want to send a packet from there to there. And each dot is an IP address in that subnet. And obviously there is all gateways. So if the packet gets to that gateway's got a couple of routes. But now what happens is, this is the case, it can actually happen, where there's two routes to that specific subnet. Then it will usually load balance the two. So maybe the first packet will send this way and the second packet will send another way. It also has ways of measuring the latency on those routes to determine the fastest route and all sorts of other techniques. They do sort of a bit of a load balancing technique. So, but this doesn't always happen. Most of the time there's just one route. But now you've got an idea where this gateway is configured if the subnet is that, or that, send it to that gateway. So there might be multiple subnets on the same gateway. As soon as the packet gets there, that one knows that it's going to this subnet, it must send it to this gateway. And this gateway sees, oh, okay, cool. The device I want to reach is on link. It's on link, it's on the same subnet that I'm in. Just send it to that subnet. Or send it to the IP address on this subnet. Okay, so a packet gets routed through the internet. There is a command that you can actually use, maybe I must actually also add it here. It's called traceroute. Traceroute gives you the route that the packet physically travels. It'll print out gateway IPs. And it'll even ping those IPs, so it'll tell you what the latency is on that gateway, which is quite cool. That uses the ICMP protocol. Okay. Root.print is the Windows command, by the way. In Linux, you can say root space -n. Okay. Oh yeah, another very important thing when you set up routing, you always need to make sure that both ways work. Because it's most of the time, when you do want to send a packet somewhere, that guy on the other side is going to send the packet back to you. 99% of the time, that's going to be the case. Where if you dispatch a packet somewhere, it wants to come back. So that means that as a packet travels there, from here to there, everything along the way needs to have a routing entry for that subnet. If it doesn't, it's not going to wait to send it, the packet's going to be dropped. Similar, obviously, if it gets there and that guy replies, now it switches around. Now the source is there and the destination is there. Now, all the gateways back needs to know the destination of that subnet. Otherwise, the packet doesn't come back. So sometimes when you configure networks, nothing works. And you just can't figure out why. You can't connect, nothing works. But if you look at the routing, it's set up properly. Just flip it around. See if the back route works. Sometimes it does work. Your packet does reach the other side. But because there's no packet back, obviously the connection can't be established. So then it looks like nothing's working. But it is actually halfway working. You just need to look at the back route. Okay. So yeah, just keep that in mind. So when we configure routes, all the devices along the way needs to know both sides of it, where the subnets are, the source and the destination. Okay, now I think we're done with routing. Okay, is there any questions here? Do you understand it at least? Or some of it? Okay. You can obviously watch this video over, and then you'll, if you don't understand something, that will help. At least you know what to Google.